Today we're going to start with the worksheet called The Ranch at Shady Acres. Okay? A rancher at Shady Acres can afford up to 300 feet of fencing to build a rectangular pen that must enclose an area of at least 2,600 square feet. So, especially for the area around us, is that a real-world problem?
Yes.
Absolutely, right? Does anyone not know people that don't keep animals? We all know people that keep animals, right? We all know people that have to build pens, maybe not this big, but we all know people that have to build pens for their different animals, right? Okay, so this is definitely, especially for our area of the world, this is a real-world problem for us, okay? So for the purposes here, for this particular problem, we're going to let x be the larger of the two dimensions, okay? So let's determine which of the dimensions listed below satisfy the restrictions on the enclosure's necessary perimeter and area. All right? So someone tell me, first of all, someone tell me how you find perimeter of a rectangle. 2x plus 2y. So that's the mathematical way, which is wonderful. How else might we say, how do you find the perimeter? Add up all the sides, right? Okay, 2x plus 2y takes care of the math. Add up all the sides is like the English translation of that, right? Okay, so what if the length was 81 feet and the width was 58 feet? How would we find the perimeter? 2 times 81 plus 2 times 58. What is that? It's at least 12. That is correct. So what is 2 times 81 plus 2 times 58? I'm not doing this math for you today. You should all have your calculator on your desk. You're going to do the math today. 2 times 81 plus 2 times 58. 278. Now you're not allowed to answer for a while. Okay? How do we find the area of a rectangle? X times y, length times width, right? So if this was the rectangle, this is the one we're talking about right now, how do we find its area? What is 81 times 58? Whoa. 4,000 what? 698. Okay? So in this problem situation, will that work? Okay, wait a second. What has to be true for it to work? You can afford up to 300 feet of fencing. So what does that tell us about the perimeter? Has to be less than 300. Or equal to, right? Less than or equal to 300. So does that work for perimeter? And what else, what do we know about area? So what does that tell us? In general, what does that tell us about the area? It can be 2,600 or more, right? So does that work? Do both of these parameters work? Yes. Okay, so somebody who hasn't spoken yet, please tell me the perimeter of this. If I have 111 feet as my length and 21 feet as my width, what is the perimeter? 260 what? 264. Somebody else tell me the area of this rectangle. 2,331. Will that work?
No.
What are the parameters or the restrictions? It has to be what for perimeter? What does it have to be for perimeter? Less than 300. It has to be under 300. And what about area? At least, so greater than 2,600. So does this work? Why? Does a perimeter work? Yeah, perimeter is fine. The area does not work. So does it work? No. What about the next one? If this is my length and this is my width, what is its perimeter? 302. Somebody else tell me the area. 4,000. Are you sure? 5,428. Okay? So, does it work? Why? The perimeter is greater than 300, and it has to be less than 300 to fit our restrictions, doesn't it? Okay? So does it work? No. What about this one? Somebody who hasn't talked yet. Tell me about the perimeter. 220. Thank you. What about the area? 2,769. Does it work? Are you sure? Prove it. The area is greater than 2,600 and the perimeter is less than 300. That's all I mean if I say prove it. Just make sure the restrictions fit. And you know I'm always going to question you, yes? That's my job. Now what? Does the last one work? Well, what's its perimeter? Somebody who hasn't talked yet. 281. Somebody else who hasn't talked yet. What's the area? Everyone's participating, or you're doing this by yourself. Make a choice. Nope. 2,460. Does it work? Why not? So the area doesn't work, right? Area does not work. Does the perimeter work? Okay, perimeter works, but the area does not work. So right now, we just made a list of 5 possible lengths and widths to figure out these restrictions, right? How many possible lengths and widths are there? Thousands. Millions. Because right now all we use is whole numbers, right? We didn't even say something like 92.5 and something like that, right? What? Oh, we did, right? We've got one with 0.5, but we could have said 92.3 and 58.7 or something like that, right? Or yes, we did 20.5, but we didn't do 20.05 or 20.506. Aren't there tons and tons and tons and thousands and thousands and thousands that we could try? You want to try them all? Yeah, me neither. Me neither. Okay? So wouldn't it be nice if there was a different way to go around doing this problem? Oh, there is. Yeah, it's like an infomercial. There is, right? Rather than making a list of all the possible dimensions, their ordered pairs can be graphed using a system of inequalities. What is the difference between a system of equations and a system of inequalities? Equation has an equal sign. Inequality has an inequality sign, first of all, right? What's the difference in their graphs? An equation could be linear, it could be rational, it could be quadratic. But couldn't inequalities be all those things too? If you looked at 2 graphs, could you tell which one was a system of equations and which one was a system of inequalities? The answer is yes, but you got to know how. Nope, that's a good guess though. It may be dotted. That would help us know. The shading is the major way you know. What were you saying? Tell me again. Are you sure? Okay. Shading is the major way we know if it's a system of equations versus a system of inequalities. Okay? How many solutions does the system of equations have? Maybe 1, maybe 2, maybe 3, maybe 4 if we're pushing it, right? How many solutions does the system of inequalities have? Tons, right? Anywhere in the shaded area is a solution, isn't it? Okay? So, just want to make sure we're okay with that. Now let's go on to this. Here's the restriction. Let's write an inequality that fits that restriction and then make sure we have it in a form where we can easily graph it. You okay with that? So how did we, like, what did we talk about in general when we talked about the rancher having 300 feet of fencing? He can have less than or equal to, right? So, but what is less than or equal to the 300? X is? Are you sure? Look back up at our work. What did we say had to be less than or equal to 300? Oh, the perimeter, right? If the perimeter has to be less than or equal to 300, then tell me that's perfect. Say it again. This value has to be related to 300 somehow. I agree with you on that. Okay? Why is it less than or equal to 300? He can afford up to 300, not any more than 300. So this value on this side has to be less than or equal to 300. You okay? Good. Wait, are you lying? Okay, good. Now, this is all technical and stuff. It's like, plus it's spelled wrong. Graphing form? It's supposed to say graphing form. It does not. It says graphing from. I guess if you think about it, if you want to be like, try to make out like the worksheet is exactly right, we're going to graph this from this equation. I think it's supposed to say graphing form. Nobody asked me though, so I'm just going to be quiet. Well, actually, probably not. I'm going to keep talking because I have to teach the lesson. Okay. How are we going to get this into a form that we can graph it? So, see, here's the part that we're getting to. Okay? We're getting so smart, all of us are, that we can know, well, I've got to subtract 2x for sure. But after that, what am I going to do? Divide by 2, and I can just go straight to my graphing form now, can't I? Some of us still need to show all the steps, and if you do, that's so great. Okay? But some of us can say, well, that sign doesn't change, so that's going to be less than or equal. What's going to make that sign change? If I divide by negative or multiply by negative, right? But I didn't do that. I only subtracted, and then I divided by a positive 2. So that's going to say the same. Then what's over here? Well, I have 300 and I have a negative 2x. And I divided all of that by 2, right? So I've got a negative x and a 150. Could I have put 150 minus x? Yeah, either one is okay, right? We okay with that? Excellent. So now let's look at the next restriction. The pen must enclose an area of at least 2,600 square feet. Yeah, I think it's so funny when you guys are like, I think this is the right answer, but it really is. So I'm proud of you for knowing that. X times Y, how is that related to 2,600? Greater than or equal to. So what would that look like to graph it? Greater than or equal to what? How do I solve for Y? Very good. 2,600 over X. And then what about the last one? Wait a second. When we talked up here, we only ever dealt with 2 restrictions. And now there's suddenly 3? There was really a restriction earlier, right? They built it into the table, so we didn't have to worry about it. For the purposes here, let X be the larger of the 2 lengths. That's what this is saying. Let X be the larger of the 2 dimensions, or they can be equal. So what are the 2 dimensions we're dealing with? X and Y. So how are X and Y related? X is greater than or equal. Why is it greater than or equal? Because it says, right? Yeah, it could be equal. Yeah, absolutely. Okay. So what does it look like if we're putting it into the equation where we can graph it? Y is, wait, I just thought we said greater than. Oh, excellent. Y is less than or equal to X. Got it? Now, Our instructions say use a calculator to help you sketch the graph of this system of inequalities. I sure hope that we could graph these two equations without anybody's help, not even a calculator. Do you know how to graph the line y equals x? Well, then we know how to graph the inequality y is less than or equal to x. Doesn't have a y-intercept, the y-intercept is 0, and then we rise 1, run 1. Now I know that these count by tens. I'm okay with that. Are you okay with rising 10, running 10? Isn't that still 1? Rising 10, running 10, isn't that still 1? Is this a solid line or a dotted line? It is a solid line. And what's my last question? Where do I shade? Do I shade above or below? Y is less than or equal to x. So below, right? Now I'm not actually going to shade yet. I'm just going to draw myself some little arrows. Beautiful little arrows. I think they're beautiful. Don't judge my arrows. Rude. We should also be able to graph the first one, right? This one? What's our y-intercept? 150. So down 1, right 1 is my slope. Hopefully those two we could graph by hand. No issues, no problems, no use for a calculator, right? Is it solid or dotted? And am I shading above or below? Below? Y is less than? Do I need to draw arrows over here? Why not? Yeah, I already know it's going to be below that line, right? So now I'm telling myself, now I know my solution's going to be somewhere right there, right? Okay. So what's left then to graph is this function. What type of function is that? Do you remember? Starts with an R and rhymes with ational. Oh, rational. Excellent. Good. Remember, where's my x? In the denominator. So that's a rational function. It looks like a ratio. Looks like a fraction. Remember us talking about that stuff? So I'm going to start a new document on my calendar, on my calculator. I'm going to start a new document on my calendar. Okay? That's a graph. And I'm going to let the calculator help me on this one. Okay? Now, before I even put anything in my entry line, what do I need to probably do first? Just change my window. Menu, window. What do I want to change it to? Why? What? It doesn't tell me that anywhere. Oh, it's the graph they gave me. That makes sense, doesn't it? It doesn't say set your window to 0 to 150, but it gives me a graph that goes from 0 to 150. Does that make sense to use that as my window? Good, yeah, like in English they would say use your context clues, right? Use the words around the word you're trying to figure out. Aren't we using context clues right here? Oh my gosh, it's almost like English and math are related. What? Okay, settings, 0, 150. 0 to 150. Now let's put my equations in. Okay? Negative x plus 150. I'm sorry? I'm not going to, and we'll talk about why in just a second if that's okay. Okay? I'm just going to treat them as equations right now. I'm going to treat them as equations so it'll graph it for me. Okay? We could go back and put the inequality in so it would shade, but I'll show you what it won't do in a minute. Is that fair? I need a fraction, 2600 over x. And then just an x. So here's what the graph looks like. That's pretty close to what I have. All I was missing was the rational function, and now I know where it goes, right? Okay. Now, I sometimes we can just draw it on there and we don't care, right? Today we care because we're trying to find a feasible region. We're trying to find points of a solution. So let's use menu, our analyze feature, to find the intersections. Okay, let's do that. So the first intersection I want to find is this one right up here. I'm going to find this one. Would someone please find this one? Who will do that? I would really appreciate if you would not all volunteer at the same time. Would someone please find this one? Would you do it, please? Would someone please find this one? Anyone? Volunteers? And then would someone please find this one down here? Yes? Okay, okay. All right, somebody find this one? This middle one? Okay. So if I'm going to find this one right here, it's asking me if I go menu, analyze, intersection. The first thing I have to do is tell the calculator which two graphs it's asking for an intersection. Because there's 3 graphs right here and it doesn't want to mess up. So it's saying which is the first graph I'm talking about. Well, I'm clicking on that one. Which is the second graph I'm talking about? I'm clicking on that one to find that intersection right there. I just have to click on them. So I know that intersection right there is 75, 75. Right there. Okay? So I need the other 2s. Anybody have the other 2 yet? Okay, what is it? 130, 20. Okay, I need one more. The one I don't have yet. This one down here. 5151. Are you sure it's not 5150? Sorry, that's just a little music joke. I'm sorry. Okay, 5150. Only one person's gotten it so far today. And that was Sean. Yeah. If you don't get it, I'm sad for you. I just have to say. 5151. Like right there. 5151. So this is what it looks like then. Ish. Ah, I missed that dot. Please forgive me. This time? Okay, thank you. Thank you for your grace. So where am I shading then? Above it, because it's greater? So where are they all shadable? The little rounded triangle thing? Okay. So, what we just did would not have been possible if I would have made it shade for us. It will not let you find intersections if it shades. Okay, so that's why I just put them in as equations instead of inequalities. Because yes, that'll help you shade, but then you'll have to go back and do it all over again to be able to find the intersections to find what those points are right there. Yeah, I don't want that either. Okay. You can always go back and have it shade so you can make sure you shade it in the right place. Okay, use it as a check. So I want several other possible pairs of dimensions that would be included in the shaded area. Okay, it says to include any vertices or point of intersection. We already got the points of intersection, so I would like 3 more besides the points of intersection. Okay, so what I want is 3 other than the vertices. 80, 50. Is 80, 50 in the shaded area? So it is a possible answer, isn't it? What does it mean? Go back up here and tell me what it means. What? Tell me about the story.
It would work. That it could be a length and a width.
A rancher can build a fence
That is 81 feet length and 50 width.
that is 80 feet length and 50 width.
Something like that.
Yes? Do you see what I mean? Go back up to the story. Okay. Doesn't do any good to have an answer if we don't know what it means, right? Somebody tell me another answer. 90. Ooh, 90-30. That's pretty close, right? 90-40. Just because it's close, does that mean it's wrong? 90-40. Okay. Right, I might have done a poor job of graphing, right? We could go back on the calculator and look to be sure, right? Okay. Give me one more. 120-20, also super close, especially, you know, I missed this bottom point, so 60-60, right there. Oh, that's 60-50. Oh, 60-60 is actually on the line. Is that allowed? Why is it allowed? Because it's solid. Very good. 60-60. So, this is not a question of judgment. It's a question of curiosity. Fair? How come no one said 83-42? I think there are quite a few of you that are extra, okay? I think that you're more comfortable using the numbers that are listed on the paper. Is 83-42 in the shaded area? Now, while I don't know exactly where it is, I can make a darn good guess, and it's in the shaded area, isn't it? Is 83-42, is that more correct than any of these over here? No, absolutely not. Okay? Just something for you to think about. Fair enough? Okay. Now, look at the other worksheet. This worksheet always makes me sad because now I want macaroni and cheese for lunch. And I don't have macaroni and cheese for lunch. I need a tissue. Okay. Okay, thank you. Okay, I'll live. All right, here's my tissue. Okay. How is this problem different than the one we just did? We have 3 variables this time. It's a three-dimensional shape and not just perimeter and area, right? We have surface area and volume. But you know how to find volume, don't you? Length times width times height. How do I find surface area? It's a little bit more involved, but still it's something you can do, right? You find the surface area of this side and multiply it by what? 2, because there's 2 of them. There's one here and there's one over here, right? Then you find this surface area and multiply it by 2 because there's a front and a back. Then you find this surface area and multiply it by 2 because there's a top and a bottom. Right? Remember how to do that? Kind of is fair. It's fair. We can work with that. I need you to fill out the volume and the surface area and figure out if these will work. Then I need you to take these equations that they actually even already gave you, graph them, use it as a system, graph it, find possible solutions that are not vertices. Okay, I know that vertices will work. You know that vertices will work. I want you to choose things that are not vertices. Fair? Okay, real quick, let's fill out the table at the top so that we're not spending all of our time filling out the table at the top. Pick one of these, fill it out, and then come back here and tell me what it is, and I'll write it on my paper so we all have everything in the top. Do it quick. Pick one of them. 96. Thank you. 92. 192. Thank you. 300. 90. Now surface area. 2 times 4 is 8. 8 times 2 is 16. 4 times 12 is 48 times 2 is 96. 2 times 12? 24 times 2? 48. What is 16 plus 96 plus 48? 160. You get the idea? Fill in the next 3 for me. Somebody do it. Mm-hmm. For this one, it's 208. Anybody have the third one and the fourth one yet? I will. What's 5 times 10? 50 times 2? 100. What is 10 times 6? 60 times 2? 120. What is 5 times 6? 30 times 2? 60. What is 100 plus 120 plus 60? 280. So I'm finding the area of this side, multiplying it by 2. Then I'm finding the area of this side and multiplying it by 2. And then I'm finding the area of that side and multiplying it by 2. Okay, you got it? So what's the last one?
Is it 132?
Nope. It's close. 126. 126. Okay? So tell me, will the first one work? The box must be twice as long as it is wide. The volume must be at least 100. No. And look, no. I already know this last one's a no because the volume's not at least 100, right? The surface area must be no more than 250.
So the
Third one's a no because of surface area. Only one works. So, use the following inequality can be used to describe one of the restrictions. Explain why and solve it for y. Then this one can be used to describe another situation. Explain why and solve for y. Graph both of them and figure out where to shade. Find your restrictions. Okay?